Hello guys, welcome to benzblog. Well, today we're going to talk about, since we're talking about the excitation system, now I will show you the example of one of our excitation system, which is this one is the SHUNT AVR. So this one is R250. So we're going to talk about, and let's simplify all the rest of the functionality of this kind of AVR. So guys, I will give you the example for our SHUNT AVR. This is as I told you, this one is R250. Okay, so as of here you can see this one is frequency and lamp configurations. So here is the pictures. We have the 50 and 60, and this one is your external potentiometer. You can connect it here. So you have around or you need something 1000 ohms for this external potentiometer. Here is our stability, and this is your voltage adjustments. So in here you can adjust everything. 50 to 60, we have here the off lamp, and we have the lamp for 30% and the lamp for 25%. So this is at 50 hertz. We have here the 60, you have the lamp off, and you have also the 13 and 25 lamp percentage. So here we have the 65 ni and 57 ni if you are needed this one for your over and under frequency, this one. So you have the special, which is number 8, and you have the number 9 for 47 for and 47.5 hertz lamp off. So this is all 65, 57, this is all lamp off. So I'm talking about what is the lamp. So lamp is meaning to say this one is I will give you the meaning for that. LAM is the load acceptance module. So that is the meaning of the LAM. So at the top here, let's go back for the R250. We have the sensing voltage of 110 to 0, and you have the exciter field positive E and negative E. This is the connections where you can connect your exciter field. Okay, so let's go around here. So no need for that. Okay, we just go for the important things. So here is your wiring diagram for your R250. This is the shunt excitation. So meaning to say, shunt excitation, this is the alternator with the shunt excitation is self-excited with an 250 voltage regulator. So meaning to say, if you see shunt, this is what we call the shunt or the self-exciting system. So this is regulation. This regulator monitors the excitation's current as functions of the alternator output voltage. So very simple design, and the alternator with shunt excitations had no sustaining short circuits. So this is AVR which cannot make a short circuit. For example, if you have short circuit, it cannot produce voltage. It will sudden shut down for that. So it is no sustaining short circuit. So unlike to the RF and the PMG, if you have the short circuit, as I talked about last vlogs, you can have a short circuit of 10 seconds period. So that is the difference. So this one, the R250, is the shunt, which is what we call the self-exciting AVR, and this one is now no sustaining short circuit. Okay, there's no short circuit capacity. So here is our connections. So this is your E plus and E negative is your, as I told you, this one is your excited field. So it is connected as your positive and negative. Here is where you can also inject the battery here for your excitation process. You just remove the connection here and take this wire for your excitations if you have some trouble. Okay, so your sensing is all around 110 volts only. It's we will talk about down there. So you can connect this one, not applicable for 6 leads. Okay, so this one is applicable on the 12 leads applications. You have here the 8 and 7, which is 1 coin. So where it is connected to 110 to 0 volt. So this one here is 8 and 11. You can connect also here any of this single winding. Okay, so from here, if you look around, you have the fuse here, and you have the voltage adjustment and your stability. So as I told you, this one is, you can select your frequency here and your lamp. So let's go for the characteristics of our AVR. So this one is it can operate up to 40 degree to 70 degrees Celsius. The voltage regulations around plus minus 0.5%. Okay, supply range is voltage detection is 85 to 139 volts, 50-60, and the rapid response time is 500 ms. This is milliseconds. For the transient voltage variation amplitude of plus minus 20%. Okay, so we just only talk about here the important. Your power supply protected is 8 ampere fuse, and this one is the breaking point is 30 kiloamps. Okay, so here is your under frequency functions and the lamps thresholds for positions 50-60 Hz to actions as under frequency actions, as well as the lamp setting types of selecting using the potentiometer. Okay, so warning, jumper setting must correspond to the rated operations frequency. See the nameplate on the alternator risks instructions. Okay, so what is the difference now? So here is the applications for your lamp. So the Hertz, what you mean? The Hertz hold positions of the lamp functions settings are done with the jumper. Okay, so they're talking about the jumper. So this is what we call the jumper here. This is the selective switch here. Okay, so operating at 50 Hz under frequency gradient at 0 means the threshold at 48 Hz without the lamp for impact between 30 and 40% of the rated load. So at the operations for 50 Hz, this can be applied without lamp, but the impact is only at between 30 and 40% with your rated load. So it is depends on your kVA. Okay, so where you can apply your rated load. So here at the 50 Hz, the threshold at 48 Hz with lamp at 13% for the impact between 40 and 70% of your rated load. So it is increased if you have, or if you activate this lamp positions. Okay, so lamp connections. Okay, so and the other side, number 2, threshold at 48 Hz with the lamp at 25%, it is having impact load at 70% at rated load. Okay, so at 25, let's summarize this one. At 48 Hz with lamp if you set this one at 13%, you can gain this one to 40 to 70% impact load, rated load. Okay, 30 to 40% impact for rated load. Okay, if you set this one to 25%, so it will increase to 70% of your rated load impact. Okay, so here is our 60 Hertz under frequency gradients. So this is number 3. So at the first time we were talking about 50, so now we are talking about 60. So number 3, threshold at 50 Hertz without LAM, impact between 30 to 40% of the rated load. Okay, so this one is without LAM, so you can apply only at 30 to 40% rated impact load. Okay, so next is our threshold at 58 with the lamp at 30%. The impact load can be applied to 40 to 70% rated load. Okay, so we have here number 5, threshold at 58 Hertz with the lamp at 25%. It can be applied up to 70% rated impact load. So this one is at the set point of 60 Hertz. So as you can see here, we have the 50 and you have the 1 positions, which is 13% LAM, and number 2 is your 25% LAM. So 50, 60, if you applied same LAM, this one, the load acceptance module, so 13 is only can be applied at 40 to 7 where is that, 40 to 70 acceptance load. Okay, so at here at 60, same, 13 to 25% can be applied by using your set points. Okay, same ranges. So you have at 13, 40 to 70%. If 25, directly to 70% impact load. This is always rated at your what kVA you have, so you know how to calculate it already, that one. So the other specifications here is the rest of the LAM, so like 6557. So this is here, so I don't have the time. We are just talking about the important things we are only mostly using. So here the our AVR potentiometer should be at 1000, or this one is 1 key ohms. So this one is range 2 plus minus 5%. So just remove the ST4. So what you call that, the ST4, where you can find that one. So ST4, this is the jumper as I told you from the previous one. This is the one, the ST4. You remove this one and connect your wiring for your potentiometer. This is 2 wire. Okay, so back from down here. So as you can see here, this is the graph for your LAM. So it is advised to use the LAM 25% impact to 70 at genset rated power. So you have the voltage and your frequency. So this is your LAM position. Okay, so this is your 48 and 58 hertz. So it's 50, 60. It's correspond at 50, 60. So this is your LAM. So that is your graph at this point. Okay, so here is the LAM system integrated as AVR is active as a standard. It can be adjusted up to 13 to 25%. As I told you, 13 to 25% here. 50 or 60 you can apply. Okay, so here the applications of load rotation, the speed of the generator set decrease when it is passes below the preset frequency. So here on the application of the load, so the rotation speed of the generator, so if it is reaching to the preset frequency, so he said here that the rotation of the speed is decreased, so it is little slower down. So in order if passes below the preset frequency threshold, the lamp causes the voltage drop by approximately 13 to 25, and consequently the amount of the active load applied is reduced approximately 25 to 50% until the speed reaches to the value. So they will reduce that one if as they say, if reaches to the preset frequency, so it will slower down or decreases the rotation of your speed unless it will not reaches to the until the speed reaches to the rated value gain. Okay, so it is also reduce the voltage approximately, reduce or drop approximately to 13 to 25% consequently. Okay, so here is the graph for that one. So the lamp is not only helping the impact load, it is also helping the frequency to gain fastest as he can. So here during the impact load, the functions help the generator to return to its rated speed faster thanks to the gradual increase of the voltage according to the following principle. So if the speeds drop between 46 Hz, the rated voltage follow as the gradient as the restored. So okay, so if the speed drops below 46, hence since the engine needs more help, the voltage follows as the gradient returns to the reference value. So here is your graph. So this is your frequency and this is your time. So as you can see, if you drop to 46, it will look at the slope. So there is a big difference. Now if you apply this one, the lamp, so here is the graphs here, it is more faster to recover your frequency. Okay, so this is only the graphing for the everything that you are applied the lamp, how many percent. So this is the graph between that one. So now for here, let's talk about the fault findings for our AVR. So this is more important, this functionality. So for example, your AVR is no voltage at no load startup. So you have to do is to check this one, check the causes. Means if no voltage and no load during the startup, meaning either there is no residual magnetism. So if there is no magnetism, so here is your actions. So you can connect a new battery for 4 to 12 VDC volts with the terminal of E negative and E plus, respecting to the polarity to 2 to 3 seconds. So follow the polarity if you are doing this excitation. Okay, so the effect is the alternator builds up the voltage. It's still correct when the battery is removed. The alternator builds up, but its voltage does not reach to the rated value when the battery is removed. Okay, so you have to check the connections of the AVR reference at the AVR. What do you mean? Check the connections of the voltage reference to the AVR, fault diodes, armature short circuit. So this is what you're going to check. Okay, for example, you excite and it is built up, and once you connect back your AVR, or the connections is already fully connected, and same, there is no value voltage output. So you have to check these things. Check the connections of the voltage or the AVR connections. Check the diodes if it is faulty, and check the armature if it is short circuit. Okay, here we are. More alternator builds up, but it is voltage disappear when the battery is removed. So you have to check the faulty AVR, or this one is either faulty AVR, or you have to check the field winding disconnected, main field winding is open, check the resistance. So you have to check all of those things. The AVR itself, you have to check either this one is faulty, the winding connections, the main field if it is open or it is in a good condition. So also you have to check the resistances of your windings. Okay, so for example, you have the voltage is too slow, so check the drive speed. Okay, it means the drive speed, if it is reaches to the correct set points. For example, if you are using the 50 Hz, or if you're using the 60 Hz, or if you see speed, this one is correspond to 1500 RPM or 1800 RPM. Okay, so what you're going to check, so you have to check the speed, you have to check the AVR, you have to check same the short circuit rotations of the diode, if it is born, the main winding, if it is open or short circuit, and the resistance. Okay, same what you're going to check. So double check also your speed, if it is either slow or not reaching to your nominal speed. Okay, in the configuration we have the nominal, we're having the over and under speed also. So you have to check that one in order to identify what is the problem, either the AVR or it's only the speed is the problem. That's why it cannot regulate the proper voltage for you. So next here is voltage is too high, just adjust the voltage potentiometer, adjust also what is they can affect for your AVR. Okay, so either this one is your diode or the AVR itself is the faulty. Okay, this is the thing you have to check. If it is over voltage, check if your AVR is faulty, or check if it is diode is short circuit, or if it is open, or what else you can be affect this voltage why it is too high. Okay, so voltage oscillations adjusts the stability potentiometer. So oscillations meaning this one having the fluctuations, so just adjust the stability potentiometer, and you have to check the speed and the possibility of the cyclic irregularity. So if there is also the hunting of your engine, so it will also affect your voltage. Okay, because since the engine is the one who drive your alternator, so if the engine is not unstable, so it also affect your voltage stability. Okay, so lost connections, faulty AVR, speed is low on the load. So this is the things you are going to check and monitor during your troubleshooting. Okay, voltage correct at no load and too low when it is loaded. So run at no load, check the voltage between E and on the AVR, E plus and E minus on the AVR. Okay, so this is if you have the correct voltage at no load, and if it is having the load, it will drop the voltage. So you have to check this E and E positive if there is some voltage output to excite your exciter field. Okay. So this is how you check the fault finding. This one, faulty rotation diode, short circuit on the main field, check the resistance, faulty exciter armature. Okay, so if there is a voltage, but when you put the load, it will drop or it will go to 0 volts. So you have to check E plus and E minus here. Based on my understanding, you have to check if this one have the voltage output, and also you have to check the diode, the main exciter field, if it is short circuit or open. Check the resistance of each of the winding, and check your exciter armature if also open or if it is faulty. So this is how you can troubleshoot your AVR in this kind of a problem. So here also voltage is disappear during the operations, same as here. Check the AVR source of pressure, rotation diode, replace the defective components. So almost same, there's no difference. So exciter winding is open, fault exciter armature, faulty AVR, main open circuits. This is the common things you have to check if you are encountering this kind of troubleshoot, or I mean this kind of problem. So you have to troubleshoot that in this way. Check everything as I mentioned here to find and fix the problem. So that's all that we have here, that are the importance of this kind of AVR. But don't worry, this AVR or these connections is no sustaining short circuit capacity, so you are safe from this short circuit. So if you have short circuit in your load, so nothing to worry, because this one is shut down itself. It cannot produce more voltage during the short circuit. Okay, so shunt, let me clear that shunt excitation system, which is the self excitation system. So this excitation system is no short circuit capability or capacity. Yeah. Okay, so you have only the 4 connections, which is the sensing and your exciter field connections. This AVR is only at 110 voltage sensing, 0 to 110, but here I saw something that is more than 280 to 135, like that. Okay, so this AVR is also have the LAM functionality, or the load acceptance module, which is you can apply this one 50 or 60 at 13%, 25% load acceptance for your impact application. Okay, so once again, 13% is you can apply the impact load for 40 to 70%, and your 25% is directly at 70% impact load you can apply. Okay, I will review it if I am wrong. Yes, 70%. Okay, same as 60 at 30% LAM, so you can apply at 40 to 70% impact load, and your 25% at 60 Hertz, you can apply for 70% impact load. So that's how the usage and the functionality of this kind of AVR, the shunt excitation. Okay, so I think I explained already all the common and the important things that we need to know this type of AVR. So if you have some questions or doubts, just comment down to our YT and I am willing to answer that. I am also open-minded for any of the questions that you can ask, and you can also give your idea if you have encountered this type of AVR. Okay, so once again, benzblogs is here. Thank you for watching and see you again. Have a nice day to you. Bye bye. See you again in my next vlog. Bye bye.